Hello everyone, welcome to our YouTube channel, World of Software Testing. So in this lecture, we'll discuss about the black box testing techniques. So we have already taken the overview of BBD techniques in our previous lectures. So let's start understanding all the techniques one by one. So what are the black box testing techniques? So the black box testing techniques can also be termed as a test design techniques or the test data design techniques and the test case design technique. So as the name suggests, test design techniques or the test data design techniques or the test case design techniques. So basically the main goal of test design techniques is to reduce the data and increase the test coverage. The data which we are going to use for testing, which is termed as a test data, and the increase the test coverage. So by reducing the data which we are going to use for the testing, it has to be covered all the scenarios of the testing. So the data which we have prepared to as a test data, with that data we should be able to cover all the scenarios of the testing. So this is the main goal of test design techniques: reduce the data and increase the test coverage. The test case design techniques helps to design better test cases and reduce the number of test cases to be executed. So these are the main goals of black box testing techniques. So these are the types of black box testing techniques. The first one is the boundary value analysis. Second one is the equivalence partitioning, also termed as the ECP. The third one is the state transition technique. And then the fourth one is decision table testing technique. And the last one, that is the error guessing technique. So these are the 5 types of black box testing techniques we have. So let's understand the boundary value analysis, or also termed as a BVA, in this tutorial. So let us understand the boundary value analysis now. So why we need the boundary value analysis or this kind of test design techniques? So the practically due to the project timeline and the budget considerations, it's really not possible to perform the exhaustive testing for each set of test data, especially when there is a large pool of input combinations. So let's say if we have here this is a test marks test text box, and which accept the marks between 120 and 180. So if you want to test this text box, definitely we cannot do the exhaustive testing and can test let's say from 121 to 179. We cannot test like this. So there should be some special technique to identify the or maybe we can say improve the test data here. So we need an easy way or a special techniques that can select the test cases intelligently from the pool of test case, such as all the test scenarios are covered. So here we have 2 techniques basically. The first one is the boundary value analysis, and second one is the equivalence partitioning. So equivalence partitioning will discuss in the upcoming tutorial in more detail. So here we will discuss only boundary value analysis. So we can use the BVA analysis to improve this kind of test data here and reduce the test data and also in parallel improve the coverage. So the boundary value analysis is based on the testing the boundary values of valid and invalid partitions. The boundary value analysis, that is the BVA, is one of the black box test design technique which is used to find the errors at the boundaries of input domain. The test the behavior of the program at the input boundaries rather than finding those errors in the center of the input. The behavior at the edge of the equivalence partition is more likely to incorrect than the behavior within the partition. So boundaries are an area where the testing is likely to yield the defects. So the basic idea in the boundary value testing is to select the input variable values that is at their minimum. So if we consider this here, this example here, so the range is 120 to 180. So this is minimum and this is maximum. So in case of boundary value analysis, we find out the values like the minimum, just above the minimum, just below the minimum, a nominal value, just below the maximum, maximum, and just above the maximum. So here we find out some values, that is a minimum -1, then this is minimum, this is a nominal value, and then min +1. Similarly, for the maximum range, maximum -1, then maximum, and then max +1. So in this way we will find out some of the boundaries here, and then this is minimum 120 minus this is 119, then this is 120, and then this is 120 plus 1, so 121. Here 117, sorry, this is minus, so 179, then this is 180, and this is 181. So if we get these 6 values to test instead of these values from 121 or 120 to 180, so we cannot test such kind of thing with 60 values. We cannot try the 60 values entering this text box to test this particular text box. So we can find out these boundaries here, boundary and nominal values, with the help of BVA analysis, and we can try entering here the first value as 119, 120, and 121. So out of this as well, 119 will be invalid value here, so this should not get accepted. Then 120 can get accepted here, this is a valid one. Then for 121 again this will be valid one. So for the maximum range again, if you try to enter 181, that should be invalid, and then 179 and 180 should get accepted. So these should be valid values. So with the help of boundary value analysis, we can quite reduce the data here as a test data, and we can perform the testing with a lesser data and having the increased coverage. So that is for each range there are 2 boundaries, the lower boundary, that is the start of the range, and the upper boundary, and the boundaries are the beginning and the end of each valid partition. So this is, if you see from 120 to 180, these are the valid values, and whatever outside here, this is invalid and this is invalid. So we should design the test cases which exercise the program functionality at the boundaries and with the values just inside and outside the boundaries. The boundary value analysis is also a part of stress and negative testing. So we'll cover this positive and negative testing as well in our upcoming lectures in more detail. So let's discuss some of the examples related to the boundary value analysis here. So here the customer requirement is that for a login page, if you consider any login page, there must be the username and then a password. So there should be some two text box here for this username and password. So the customer requirement is that for a login page, username text box field should contain 6 to 9 characters only. So if you see here, so this is a username and it must contain only 6 to 9 characters only. Okay, so let's find out the BVA. So in case of finding out the BVA, we need to find out the valid values and the invalid values here with the help of the boundary value analysis. So here if you see, the range is 6 to 9. So the minimum is 6 and maximum is 9. So as we already seen, we need to find out maximum. This is the nominal value, then just above the maximum and just below the maximum. So maximum plus 1, maximum minus 1. So 9 plus 1 10 and 9 minus 1 8. So whatever we need within this range, that should be valid, and whatever outside, so if you see here, let's say 6 9, so this is a valid range, and whatever outside here, this should be invalid. So here max plus 1 should be invalid, and here max minus 1 should be invalid. So max plus 1 going as 10, so this is invalid. And then again for the minimum, again this is nominal, min minus 1 just below the minimal and just above the maximal, just above the minimal. So minimum minus 1 is invalid, which we have already discussed here. And as min plus 1, this is 7, this is valid. So if you want to test this text box here, so we should try the values valid values here. If we are using the valid values and if it is getting accepted, this is a positive testing, so that should get accepted. And if we are testing, if you are trying to use the invalid values, this should not be accepted in this user box because those are invalid values. Similarly, take a next example here. So now the customer requirement is that the login page username text box field should contain maximum of 10 letters. So now we know the maximum is 10. So definitely there must be something, right? So minimum should be 1. So this is the range, that is 1 to 10 we have here. So again min minus 1, that is 0, which is invalid, and then 10 plus 1, which is 11, which should be invalid. So these two are the invalid values. So if you are trying to enter these values, those should not be accepted, and if we are trying to use the valid inputs, that should be accepted. So the which we are using with the valid inputs, that is called as a positive testing, and which we are trying to use the invalid, that should not be get accepted, which is a negative testing. So similarly we have done here as well. This is 1 to 10 range, minimum is 1, maximum is 10. So again for maximum, this is nominal value, just above the maximum, just below the maximum. So above maximum is invalid, and here also min minus 1 is invalid. So this is the second example for the BVA. Now there are some limitations on the BVA as well. So it works well when the product is under test. It cannot consider the nature of functional dependencies of the variable, because here we are just checking the input boundaries here on the for the text box. So there is nothing to do with the functional dependencies, and BVA is quite rudimentary. So these are some of the limitations of BVA, the boundary value analysis test design technique. So thanks for watching this video. Hope you all like this. Please do subscribe our YouTube channel for such more interesting videos on the software testing concepts. Also click on the bell icon to get the latest updates on our YouTube channel. In the upcoming lectures, we'll dig further into the other test design techniques such as equivalence, partitioning. So thanks for watching.